You're driving in your car going 20 meters per second when you see a deer running across the road ahead of you. It takes you 0.65 seconds to apply the brakes, but when you do, you slow your car down at a rate of 7 meters per second squared. How far does your car go from the time you see the deer until your car stops? For this problem, we are initially going to be going 20 meters per second, but it's going to take us a little bit of time before we actually are able to apply the brakes. So we have to do this problem in two different parts. The first part, we're going to figure out how far we go before we start to slow down. And in the second part, we're going to figure out how far we go after we do start slowing down, and then we can add those two distances together. We can't do them both in one because we have a different acceleration at the beginning, no acceleration, and at the end, an acceleration of -7. So we'll do the before braking first. Before braking, our velocity is 20 meters per second. We're going to be doing this for 0.65 seconds. And we want to know how far we go during that time. We only have one equation for constant velocity motion, which is d equals v times t. So how far we go is 20 meters per second times 0.65 seconds. And that is a distance of 13 meters before we even start to slow down the car. Now, once we start to slow down, our initial velocity is still going to be 20. And we're going to stop the car, so we know that our final velocity is going to be 0. Our acceleration is to the left, because if we're moving right, our acceleration has to be in the opposite direction because we're slowing down. And since it's left, we know it's -7 meters per second squared. And we want to know how far are we going. That means we're going to pick the equation that does not have time in it. And that's Vf squared equals V naught squared plus 2AD. We're going to be solving for D. So the first thing we want to do is get rid of that V naught squared. We always want to get rid of addition and subtraction things first. So since we're adding two terms, we want to get rid of that term by subtracting it to the other side. So on my left side now, I have Vf squared minus V naught squared, and that's going to equal 2AD. From here, we can solve for D by just dividing the 2 and the acceleration out. So the 2's are going to cancel, so they're going to go away. And the A's are going to cancel, they're going to go away, leaving me with just D on the right side. We can plug in our numbers to finish this up. Vf squared, well, that's just 0 squared, minus the initial velocity squared, that's 20. And that's going to get squared, all divided by 2 times -7 meters per second squared for our acceleration. Don't forget, the unit here has a square. We're not squaring the number. 7 meters per second squared, meters per second squared is just the unit. Don't square the number. And all that is going to be how far we go after we start braking. Well, 0 squared is just 0. 2 squared is 4, so that makes 20 squared 400. And then 2 over -7 is -14. Meters on the bottom cancels with square on the top. And the squares on the bottom and the top cancel as well. And that's going to give us 28.57 meters for how far I go after I start to slow down. But for the total distance, I have to add how far I went before I started to slow down to how far I went after I started to slow down. So 28.57 plus 13 is a total displacement or total distance traveled of 41.57 meters for the total distance traveled before the car stops.